Hi everyone, Assalamualaikum. In this video, we are going to discuss partial derivative for implicit functions, example 3 from previous semester papers. Use partial derivatives to find dy over dx of ln 2 plus x equals to cubic root of y minus x squared over y squared. Hence, find the gradient of the tangent line to the curve at the point -1, 1. Alright, to solve this problem, first step, bring all the terms to one side and write the function given as f. Right? So from here, we move cubic root of y to left hand side and we move minus x squared over y squared to the left hand side. So we get this. Okay. Then we denote as f. F equals to ln 2 plus x and then minus cubic root of y plus x squared over y squared. When we move positive here, we get negative. When we move negative here, we get positive sign. Alright. After that, step 2, find fx and its value at the given point. Okay. Alright, from f equals to ln 2 plus x minus cubic root of y plus 1 over y squared x squared, then we can find fx. Okay. Before that, fx means partial derivative of f with respect to x. We treat x as a variable. Okay. So to avoid error and easy to differentiate, we write variable x in different colors and then we put at the back. From here, since we want to differentiate x squared here, so we can separate constant and x squared here. Okay. We treat y as a constant. Right? To differentiate ln 2 plus x, we can refer from here. Okay. Let's say we have ln 2 plus x. Okay. Alright. Now we have ln 2 plus x. So when we differentiate ln 2 plus x with respect to x, first we have 1 over 2 plus x and then multiply by, we differentiate the function inside ln. We differentiate constant 2 equals to 0 plus we differentiate x with respect to x. So we get 1 here. Okay. So that's why we get this. Alright. And then y we treat as a constant. So means that cubic root of y is also constant. And when we differentiate constant, the answer equals to 0. Right? And then from here, we treat y as a constant. Let's say we replace y equals to, or let's say we just imagine constant 1 over y squared here equals to 4. Okay. So we have 4x squared. Then to differentiate 4x squared, we already know the answer equals to 8x. But before that, actually, we just keep the constant 4 in front. Then we differentiate x squared using power rule. So we get times 2x here. So same goes to constant x squared here. Okay. We just keep the constant 1 over y squared here. Then we differentiate x squared. So we get 2x here. Okay. Multiply by 2x here. Right? And then we can simplify. So we get fx equals to 1 over 2x times 1 equals to 1 over 2x and then plus 2x over y squared. So this is our fx. Okay. Then we can find fx at the given point -1, 1. Okay. At the point -1, 1, fx equals to 1 over 2 plus x, we replace by -1, plus 2 times x, x we replace by -1. And then over y squared, y we replace by 1. Then we simplify, so we get here 1, and then here positive and negative here, so we get minus 2. So our fx equals to negative 1. Right? Now we done find fx and its value at the given point negative 1, 1, which is equals to negative 1 here. Right? From the previous slide, we get fx equals to negative 1. Okay, then we can continue with step 3, find fy and its value at the given point negative 1, 1. Okay, we can find fy from f. Okay, then fy equals to this. Okay, how we get this? Alright, fy is partial derivative of f with respect to y. We treat y as a variable, and at the same time we treat x as a constant. Okay. Alright, since we treat y as a variable, so we can write y in different colors, and then we can rewrite cubic root of y in terms of exponent, which is y to the power of 1 over 3. And then from here, to differentiate x squared over y squared, since we treat y as a variable, okay, we can move y to multiplication of y to the power of negative 2 here using the properties of indices. Okay. Alright, so from here we can differentiate. X we treat as a constant. So 2 plus constant equals to constant. And non-constant equals to constant. Means that all of these are constant. So when we differentiate any constant, the answer equals to 0. Okay. And then to differentiate y to the power of 1 over 3. Okay. Y we treat as a variable. So we can use power rule. Okay, from power rule, if we have y to the power of n, we have n y to the power of n minus 1. So we can apply here. Okay, we move 1 over 3 to the front and then y. Okay, and then 1 over 3 minus 1 equals to negative 2 over 3. Alright. And then to differentiate x squared y to the power of negative 2, x we treat as a constant, means x squared is also constant. Okay, means we can imagine, let's say we have constant 4 and then y to the power of negative 2. Okay, we already know when we differentiate for y to the power of negative 2, the answer equals to negative 8 y to the power of negative 3. We multiply negative 2 and 4 here. But actually, before we get negative 8y to the power of negative 3 here, what we do is we just keep the constant in front here. Okay, and then we differentiate y to the power of negative 2 using power rule. We move negative 2 to the front, and then y, and then negative 2 minus 1 equals to negative 3. Same goes to this. Okay, alright. Here, x squared is a constant. So we just keep the constant in front, okay, like this. And then we differentiate y to the power of negative 2 using power rule. So we get negative 2y to the power of negative 3. Okay. Then we simplify, so we get fy equals to negative 1 over 3 y to the power of negative 2 over 3, and then minus 2 x squared y to the power of negative 3, right? And then, after we find fy, we can find fy, the value of fy at the point negative 1, 1, okay? So, from fy here, we replace y equals to 1, okay? We replace x here equals to negative 1. We replace y here equals to 1. Alright, 1 to the power of any values, 1 to the power of positive value, to the power of negative value, to the power of fraction, negative fraction, to 1 to the power of 0 is equals to 1. Okay, so we have Fy equals to negative 1 over 3 times 1 equals to negative 1 over 3. And then from here, we cannot multiply negative and negative here. But we need to simplify negative 1 squared first. Negative 1 squared equals to positive. So positive times negative equals to negative. And 1 to the power of any values, to the power of positive value, to the power of negative value, to the power of 0 is equals to 1. Okay, so that's why we get minus 2 here. Okay, then we simplify, so we get Fy equals to negative 7 over 3. Alright. Okay, then we can continue with step 4. Okay, use dy over dx equals to negative fx over fy. Okay, so from the formula dy over dx equals to negative fx over fy, so we have negative in front here, and then we replace fx equals to negative 1, and we replace fy equals to negative 7 over 3. Right? And then from here, we have negative times negative equals to positive times negative, so equals to negative. Okay, if we have negative sign equals to odd numbers, okay, we have negative sign here. Okay, negative and then 3 over 7. So this is our dy over dx. Alright, so this is the final answer. Okay, because we want to find the gradient of the tangent line. Okay, so this is the gradient. Okay, equals to negative 3 over 7. Right? Coming up next, extremum points. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.